A tsunami can move faster than a Boeing 737, hitting over 500 miles per hour, without warning, without mercy. In the Pacific Northwest, the only thing between survival and disaster is what you do in the critical moments after the ground stops shaking. Most people will hesitate. Most will die. What's the one thing you can do to survive a tsunami? And why do so many get it wrong? Water doesn't just move, it transforms into a force that rewrites the coastline. When a tsunami is born, it isn't the kind of wave most people imagine. These waves don't rise up in the open ocean. They surge forward as a hidden wall, the entire water column set in motion from the sea floor to the surface. In deep water, a tsunami can race at more than 500 miles per hour, matching the speed of a jet airliner. There's no roaring crest, no warning siren offshore. Just a massive, mile-wide pulse that slips beneath ships and buoys, barely noticed at sea. The secret to this speed lies in the physics. Ordinary waves are only skin-deep, shaped by wind and surface tension. A tsunami, triggered by a sudden shift in the ocean floor, pushes the whole depth of the ocean forward. Its wavelengths stretch for miles, sometimes longer than the distance between cities. That means the energy isn't just at the top, it's packed through the entire column, giving the wave its relentless momentum. As this energy rushes toward land, the ocean grows shallow. The wave slows, but it doesn't lose power. Instead, all that force piles up, compressing into a rising surge. In moments, what was a barely visible ripple in open water transforms into a wall that can tower over buildings. The shoreline becomes a trap, offering only seconds to react before the water arrives. There's no time to second guess. The tsunami's speed gives almost no margin for error. In the time it takes to tie your shoes, the wave can cross entire towns. Every second counts, and hesitation can be fatal. This is why survival depends not on technology or warning systems, but on recognizing the physics at play. The whole ocean moving as one, closing the distance with terrifying speed. The window for escape is measured in heartbeats, not hours. On December 26, 2004, a magnitude 9.1 earthquake ruptured the seafloor off the coast of Sumatra. The resulting tsunami swept across the Indian Ocean, killing more than 230,000 people in 14 countries. Entire towns vanished in minutes. In places like Banda Aceh, the water reached nearly 100 feet high, leaving behind only foundations and tangled debris. News footage from that day showed families searching for each other in the ruins, and survivors climbing onto rooftops or clinging to trees as the water surged inland. The scale of loss was almost beyond comprehension, a single morning that changed the lives of millions and redrew the world's map of disaster risk. Events like 2004 are not rare accidents. Most tsunamis strike without warning, and the deadliest ones are born along the edges of tectonic plates, where one slab of the earth dives beneath another. These regions, called subduction zones, ring the Pacific Ocean in a horseshoe-shaped band known as the Ring of Fire. Over 80% of all tsunamis on record have started here. Japan, Chile, Alaska, Indonesia, each has faced waves that flattened coastal cities and erased generations of memory in a single afternoon, but the Pacific Northwest is not immune. Just offshore, the Cascadia Subduction Zone stretches from Northern California to British Columbia. It is the boundary where the Juan de Fuca plate grinds beneath the North American plate, locked in a slow-motion collision. Scientists have mapped the fault's length, over 600 miles, and measured its capacity to unleash earthquakes as powerful as any in history. A full-margin rupture in Cascadia could rival the force of 2004, generating waves that sweep across the region's beaches, harbors, and river mouths. The threat is not theoretical. The geology beneath the Pacific Northwest holds the same potential for sudden, catastrophic upheaval. For millions living along these coasts, the next tsunami is not a distant possibility, but a waiting certainty, one that demands recognition before it arrives. On the salt marshes of Washington's coast, rows of dead trees stand with their roots exposed, a landscape scientists call a ghost forest. Each trunk tells a silent story. Dr. Brian Atwater, a geologist, traced the cause back through the rings of these trees. Every one stopped growing in the winter of 1699 to 1700. The roots, once anchored in fresh water, were suddenly drowned in salt, a sign that the land had dropped, flooding the forest in a matter of hours. Beneath the soil, Atwater's team found a buried layer of sand left by a massive wave that swept far inland. This sand wasn't from an ordinary storm. It matched the signature of a tsunami, one powerful enough to transform the coastline overnight. The search for answers didn't end in North America. Across the Pacific, Japanese villagers recorded a strange event on January 27, 1700. Without warning, immense waves battered the shore. There was no earthquake in Japan that night, no local explanation for the destruction. The event entered history as an orphan tsunami, a wave with no known parent. Dr. Kenji Satake, a tsunami scientist in Japan, compared the timing and size of these waves to Atwater's findings in the Pacific Northwest. The match was exact. The orphan tsunami and the ghost forests were two sides of the same disaster. A massive Cascadia earthquake that struck on January 26, 1700, sending a wall of water racing across the ocean. The evidence is written in the landscape and in centuries-old chronicles. Cascadia has already produced a tsunami that crossed the Pacific, devastating distant shores. What happened once can happen again. This is not theory, but historical fact. Probability isn't just a number in the Pacific Northwest, it's a countdown. Dr. Chris Goldfinger, a leading earthquake geologist, has spent decades mapping the Cascadia Subduction Zone. His research points to a 1 in 3 chance of a partial rupture and a 1 in 10 chance of a full margin event in the next 50 years. Not someday, within a single human lifetime. When the fault finally gives, the ground may shake for 3 to 6 minutes, far longer than most earthquakes. This is not just a tremor, but a signal. For everyone near the coast, those minutes are the only guaranteed warning. Tsunami waves can reach the shore in as little as 10 to 15 minutes after the shaking starts. Official alerts, even with the best technology, often take 5 minutes or more to process and send. In many coastal towns, that leaves a gap, sometimes just a handful of minutes, between the end of the quake and the arrival of the first wave. The difference between surviving and being overtaken comes down to what you do in that gap. Behavioral studies and real events show a pattern. Hesitation kills. After the 1964 Alaska earthquake, tsunami waves struck Crescent City, California. Some people left immediately after the first warning and survived. Others stayed, checking the shoreline or gathering belongings. Police logs and survivor accounts describe how those who waited, even for a few minutes, were caught by the waves. The numbers are stark. Delays of just a few minutes made the difference between safety and tragedy. Drills and evacuation studies reinforce this lesson. In simulations, people who move without debate or delay reach safety. Those who wait for confirmation, check their phones, or look for official instructions are often still in harm's way when the water arrives. In that moment after the shaking stops, the only choice that matters is to go, immediately, decisively, and without second guessing. The clock is running, and every step away from the shore is a step towards survival. Tsunamis can travel at more than 500 miles per hour, as fast as a commercial jet, and arrive at Pacific Northwest shores within 15 minutes of a major earthquake. The geologic evidence, ghost forests, sediment layers, Japanese records, proves that giant tsunamis have struck Cascadia before, most recently in January 1700. Scientists now estimate a 1 in 10 chance of a full margin rupture in the next 50 years. Early warning systems often can't alert communities in time. Survival comes down to how quickly people act after the shaking stops. Yet we still don't know exactly when the next event will happen or whether every community's evacuation routes will be enough. The key fact remains: immediate evacuation to high ground without waiting for official instructions is the single most effective action documented by both past disasters and survival studies. The record is clear. When the earth shakes, every second counts.